So I will summarize in a somewhat broader retrospective of the ecotoxicological aspects of pesticides. And it's not only looking back in history, but I think the example of pesticides and how they're being considered and taken care of is a good example for the future, particularly for GMOs, but also for other technologies. A few issues, and I will come back to this very slide at the end as a conclusion. A few issues that have been raised was that we have to communicate complex issues to the public and to do it in a simple way so it's understandable. But it's not always easy to do because the ultimate question is it good or is it bad? And that is a very difficult question to answer, we will see. Also, there has been a great shift of concepts, not only in terms of politics. If we think about the consideration about politicians, this term turned from positive, a minister is after all a servant, a public servant, to negative. And the same way it occurs with science, with scientists. Scientists used to be a very positive, knowledgeable, wise person, and then it turned into a creator of Frankenfood or whatever. So many topics turn around, including pesticides. And the civil society, the role of civil society is gaining importance. As for pesticides, the advantage, and that is commonplace, that the advantage is really economic, and it considers human labor, although particularly in the case of hygienic application of pesticides or biocides, there are additional implications as advantages. In contrast, or what the price is or has been, is the increasing level of residues, of various pesticide residues, the continuous chemical pressure on the environment, leading to eco-toxicological consequences, and what has been addressed several of the presenters already, new concepts in toxicology. What is, for one, is the long-term continuous exposure to subacute doses, and together with the cocktail effects. These are two issues which classical toxicology cannot really deal with. How do we respond when we are being exposed to a large number of substances on a long run at very low dosages? And these two parts, the advantages, disadvantages, is clear that basically, or very simplistically, financial and business interests are conflicted with health, ecological, or environmental aspects. And it's quite understandable, because if we look at the whole system, what we are doing, we are raising agricultural crop, which we prefer, or not prefer, intend to do it in monoculture so that it's easier to manufacture or to carry out. And which is a very unnatural situation, that we offer this single species of maize or wheat to the various pests, we actually create a larger volume of damage possible by the technology, by monoculture. So it's the role of the agrochemicals to fight those pests which we provide with food by the means of the crop. And that then this increasing use of pesticides leads to various side effects, which I will come into somewhat detail a bit later. Now, before we restrict this to pesticides only, I have to add that at least for first generation GM crops, the situation is not different. Because although the crop may eliminate the use of pesticides or some pesticides, actually the crop itself is what is producing the pesticide, or some other GM crops like the herbicide-tolerant crops actually promote the use of pesticides. So there will be side effects the very same way, originated from the plant or originated from the increased use of pesticides. Therefore, first-generation GM crops do not offer an escape or a solution to the problem, actually being the same problem. Since the 90s, a number of different concerns have been raised, starting with persistence of pesticides, now talking about pesticides, in specifically mutagenicity, carcinogenicity. Well, that is itself in a very complex issue, which I will not go into detail, but it's quite interesting. Endocrine disruption and immune suppression, which I will, of which I would mention one book by Robert van den Bosch, The Pesticide Conspiracy, the second, from the right here, which, well, on one hand it proposed biological protection methods versus pesticides, but was rather interesting that it proposed the pesticide industry as a mafia, so to speak, as a system that penetrates or rules research or development circles, academia, and by means of financing or other means controls not only the development of pesticides but also the trial of pesticides. I do remember when, as a young researcher, I read that book, I was shocked and believed less than a percent of it. I assumed that a very sarcastic, very pessimistic person must have written it, and that its conclusions are far beyond reality. These industries are very prestigious, old companies with a great reputation, and they will do everything to save their reputations, because that is the one thing that they have to, that they rely on. Well, actually, because that has been over 20 years ago now, my view has turned on that, and not because of the pesticide field, but because of the GMO field. Because I do see the very same situation emerging in the GMO field, what Van den Bosch was mentioning, maybe even more severe or harsh, actually more rude, with larger amount of profit at stake. Well, if we talk about side effects of pesticides, there are obviously side effects that are related to the mode of action and those that are not related to the mode of action of the given pesticide. And obviously, the majority will be not related. That is why these are side effects. Although, in some cases, we do have problems with the actual mode of action of the pesticide. And I will mention a few historic examples. One is Mipofox, the delayed neuropathy by an organophosphate. Organophosphates are the target. The mode of action of organophosphates is inhibition of acetylcholinesterase, neural function. And it turned out that Mipofox and other otherwise not typical organophosphates inhibit not only this enzyme but the so-called neurotarget esterase, T I don't recall, neurotarget esterase, which is in the myelin coat and causes irreversible damage to the protection of the neural the nerve cell, and causes delayed neuropathy, irreversible neuropathy, which led to ban. I mean, all of these led to the ban of the given active substance. Or another example, striking example, is the example of carbofuran within the carbamate insecticides, which had equitoxicity among insects and mammalians. On rats, it had an oral LD50 value of 8 milligram per kilogram, so it's actually a poisonous substance. it could not have been authorized by law as an active ingredient. But a much more recent problem also with a side effect related to the mode of action is the neonicotinoids case, imidacloprid, which acts on the acetylcholine receptor in the insect, but it has been claimed to be causative agent to the B colony collapse syndrome. But as I said, the majority of the side effects are unrelated to the original mode of action of the pesticides. For example, with bis-dithiocarbamate fungicides, the formation of ethylthiourea that was not predicted when the compound substance was designed was proven to be highly carcinogenic, among other effects, so led to the ban and then later reintroduction of those fungicides. Or 2,4-D, 2,4,5-T, other phenoxyacetic acid herbicides, where again it's not the active substance, but the production contamination, various dibenzodioxins were the causative agents for teratogenicity. By the way, tetrachlorodibenzoadioxide is the most toxic synthetic poison so far. The LD50 is shown there, so that was what led to the ban of 2,4,5-T. Or by pyridinium derivatives, photosynthesis 1 inhibitors, herbicides, with the main example of paraquat, which through dopa decarboxylase inhibition caused irreversible neural damages in humans. So paraquat also was or became a banned substance. The current directive for pesticides is quite strict. It really intends to exclude those toxic possibilities or possibilities for toxicity that has been identified before, and it sets a rather strict residue level for drinking water within the EU. Actually, EU is stricter than WHO in this aspect. The pesticides law categorizes a number of different pesticide categories, and it also specifies that the given pesticide has to fulfill a number of toxicity requirements. I would emphasize here that it should not reach drinking water, that no cumulative or synergistic effects should emerge with other substances, and that it should not represent an unacceptable load on the environment. Well, this is something that the law says, but what reality is not often close to that requirement. Also, as for the unacceptable load on the environment, it's a big question what the receiving environment is, and in EU it has been a subject of great debate. Under what principle we divide Europe into different environments. One is ecologically the best established one is the Natura 2000 system, which by ecological features defines 9 to 12 regions within the EU. The European Plant Protection Organization defines a 4-region zonification of the EU, and the simplistic one is a 3-zone, which is simply divides Europe into 3 zones by geographic means. Well, you can guess which one it was accepted for pesticide registration, the simplistic 3-zone model, which, for example, would mean that Hungary, let me talk about my own country, the second greatest or biggest maize grower in Europe, would fall under the same requirement with Ireland, for example, where maize is not grown at all. So this is really unpleasant that the zonification allows such a imperfect differentiation among regions in Europe. Moreover, it's not difficult to predict that legal conflicts will emerge between the pesticides law and the directive on habitats, on protected habitats. As for REACH, we have heard a lot about it, so I will not go into details. What I would mention is only the last line in the slide. What we have heard in the last presentation is that industrial chemicals, pesticides, and biocides are three issues linked to each other but not dealt exactly the same way in the laws. Biocides and REACH are very much converging, but plant protection products, pesticides, are dealt with somewhat differently. Well, for example, well, yes, if a given industrial chemical is produced or marketed over 100 tons per year, then it would be similar to requirements with the pesticides, but the pesticides are dealt under a different umbrella, so it may lead or will lead to conflicts. As we can see, and we heard, the substances in REACH, as for toxicology, the most concern is about carcinogenicity, mutagenicity, and reprotoxicity, but the second greatest group is endocrine disruptors, followed by persistent substances. Whomever would be interested, we have a recent publication on the comparison of pesticide regulation and REACH, so I can give the electronic version of that. As for the re-registration of pesticides, the great news, the good news is that in 2009, the EU has dropped out about 2/3 of its pesticide active ingredients. A great news in terms of toxicology. There may be problems for industrial agriculture, but about 1/3 remained. Not all of these 2/3 had to be banned because the majority have been voluntarily withdrawn by the manufacturer within the re-registration process. Here is a very long list of the rejected or withdrawn compounds, and I will go into a very few, just 4 examples. One is dichlorphos. It's an old organophosphate. It's a small miracle. I wonder how it could manage to stay in use since the 50s, since its introduction in the 50s. After all, it was banned, or actually withdrawn, voluntarily withdrawn, because of its proven genotoxicity and its suspected human carcinogenic properties, as was classified by carcinogen 2B. Here is its genotoxicity profile. Atrazine has been marketed since 1957 and has been proven to be an endocrine disrupting chemical, but still the debate went on for an amazingly long time before its ban in 2004. Acetochlor. It's very ironic that after the ban of 2,4-D and atrazine, acetochlor was the hope and became the number 1 or number 2 maybe herbicide in Europe. Acetochlor was the replacement for these banned herbicides, but it has been suspect for genotoxicity and carcinogenicity, and now even EFSA admits that its metabolites are mutagenic and produce reprotoxicity. So it is a subject for voluntary withdrawal in the EU. And then, last not least, well, one before the last, glyphosate. I will not talk much about it because you have heard a lot about it. What's important is that it's a legal case now for a lawsuit against EU or against government for postponing its reconsideration for re-registration. And as for a very important aspect is the cocktail effect, if we call it that way, this synergistic interaction with its formulating agent POEA. Again, for those who are interested, I have an electronic version of our publication, recent publication on that. And then last, this is the last substance. It's not really agrochemical. It's the Bacillus thuringiensis toxin Cry1AB, which is one of the toxins in a number of biopesticides, BT biopesticides, used even in ecological farming, or allowed even in ecological farming. That picture has been changed greatly since the introduction of insect-resistant GM crops. But an important issue, what I would like to raise here in terms of pesticide registration, is that the active ingredient in the GM crop and in biopesticides are not the same, are different, so should be treated differently in pesticide registration. And unlike BT biopesticides, BT GM crops are not or should not be compatible, should not be considered compatible with integrated pest management practices, because the timing of the treatment with the given active substance, in this case Cry1AB, cannot be scheduled to the time of damage. It is produced throughout the entire, the toxin is produced throughout the entire vegetation period, so it's non-compatible with integrated pest management. Again, on that paper of ours is coming out in a book at Springer Verlag, so those of you who are interested can receive a copy of that. And the recent event in Hungary, which I would like to mention, is because it touches or has to do with issues or circles of power that has been mentioned already in this conference. The Hungarian Academy of Sciences reorganized its research institute network, and so 4 of these institutes have been merged into one institute, a large agrochemical science center, so to speak. Why it is important is because the Plant Protection Institute, the 4th one from the right, where I used to work, dealt with independent evaluation of GM crops. Meanwhile, the second one from the right, the MGKI, is a developer of GM crops. So the Academy of Sciences in Hungary decided to merge its institutions and merge, therefore, GM production or development of GM crops together with the risk assessment of the GM crops. Therefore, in a way, to some extent, the way for independent research within that umbrella was, well, at least at risk. Therefore, as a result of a decision, a ministerial decision to consider the agricultural part of food safety within the global concept of food safety, both chemical safety from pesticides and genetic safety from GMOs, it decided to create a new department, a new division of agro-environmental safety, and so we moved to this other new institution, Central Food Research Institute, which I'm presently heading. This is, we will see how perspective of a reorganization, but we do hope that it will serve food safety in Hungary. Now, the conclusions which I mentioned already, you have seen this slide. I would like to mention 2 issues here, or emphasize 2 issues here. As I said, the public wants to know if a given substance is good or bad. Tell me if I should use it or not. The demand is that simple, and the answer oftentimes cannot be that simple. And if you look at the history of pesticides, there were times when you simply could, it was the same for given pesticides. You could not have told about any given pesticide that it's bad or it's causing harm or whatever, because at that time knowledge was not just there yet. So I have to disagree with the fact, particularly about GMOs, that we can communicate simple messages to the public, because the issue is still very complex and on the rise. The other issue is the shift of concepts in pesticides. If we think about it, pesticides in the 50s or earlier used to be good things, again with the simple message. Unnecessary, unavoidable things without which agrochemical production is impossible. And they turned within 2 decades or 3 decades into negative things. The public really considers pesticides now in a negative aspect. I have no doubt that the very same thing will happen with GMOs or other areas, because we are basically following just the same pathway. At the time of introduction, we just simply don't know what we are dealing with, and on the run, from use, we learn whatever disadvantages we may face in the future. So pesticides, the history of pesticides teaches us in that aspect. And what's important here is the civilian society, the role of NGOs, the role of voicing public opinions. I say, because oftentimes from agriculture or biotechnology, the claim is, why do you require that our technology should be safer than pesticides? You are using nasty pesticides anyway. And my answer to that is that if the public, or if the society were interwoven with civilian organizations in the 20s or 30s of the last century, then pesticides would have never been registered or allowed as technology. The public would have dealt with pesticides with the same feeling of at least caution as they do now. Thank you very much for your attention.